Here's a question that you might think you already know the answer to. Does water conduct electricity? And thanks to movies and television, you're probably already rushing to the comments to type something along the lines of, yes, you dingus, of course it does. But are you sure about that? What I have here is a glass of distilled water, which is about as close to pure water as I'm gonna get. And this is a DC power supply. The experiment is simple. We'll submerge our leads from the power supply into the water, then we'll use the power supply to attempt to run a small current through the water. To keep things safe, we'll target a 1/2 amp for our current and we'll set our voltage limit at 3 volts. As I start the output, you can see that our power supply immediately reaches our voltage limit. But in terms of our desired current, it hasn't yet generated anything even worth measuring, which means our little glass of water here is doing an incredibly poor job of conducting our intended current. But what happens if I do something crazy, like say, add a little salt? As you can see, as soon as I add the salt, we start conducting a current. And as I stir the salts around and mix it up in the water more, we start conducting more and more of a current. So what the heck is actually going on here? Well, as it turns out, water is a really poor conductor of electricity. Shocking, I know. That's because pure water has very few ions to carry the charge. However, most water that we come across in the wild has things like salt, minerals, and other impurities dissolved into it. It's these impurities that provide the ions to carry the charge. So, the next time you see a bad guy fire a taser into a puddle of water to electrocute Jean-Claude Van Damme, just know that it isn't the water that's doing the shocking.